When we talk about artificial intelligence, it is easy to picture a glowing digital brain. We imagine a thinking entity capable of making human-like cognitive leaps inside a mysterious black box. A neural network does not actually function like a biological brain. Instead, picture a massive, dumb mechanical box stretching as far as the eye can see, completely covered in millions of tuning dials. To understand how it works, we have to look at how data goes in. If we want this machine to recognize a photograph of a dog, we take that image, break it down into thousands of individual pixels, and feed the numerical value of each pixel into one side of our mechanical box. Inside, those numbers pass through the millions of dials, bouncing and multiplying chaotically until the machine spits out a guess on the other side. Because the dials are initially set at random, the machine looks at the pixel data for a dog and confidently declares, "Toaster." In a real neural network, those rows of dials are called hidden layers. There is no magic happening inside them. The entire process of deep learning is simply the act of finding the exact right combination of settings for all of those dials. When you first build this machine, every single dial is positioned completely at random. That guarantees every initial guess it makes will be completely wrong. Engineers build a loss function, a mathematical wrongness meter that calculates the exact distance between the random guess and the correct answer. The system's single overarching objective is to force the needle on that meter down to zero. You cannot solve this by trial and error. If you tried to find the right settings by randomly twisting millions of dials and hoping for the best, you would be twisting them until the end of the universe. Luck will not work. The machine requires a systematic, mathematical strategy to deduce exactly which dials to turn, and in which direction, to reduce the error. Gradient descent acts like a ball rolling down hills and valleys. Height represents error. The goal is the lowest geometric point. To descend, it works backward through every dial, calculating if a left or right nudge reduces the error, then simultaneously turns all helpful dials. Then it repeats the loop. It takes in a new image, makes a slightly better guess, like cat instead of toaster, and calculates adjustments again. This continuous backward nudging loop is called backpropagation. Backpropagation is the specific algorithm that calculates exactly how much each weight or bias should change to reduce the error. When people say a machine is learning, they are describing this iterative mechanical correction. As the machine adjusts millions of dials over thousands of cycles, the math can easily run out of control. Without boundaries, the cumulative adjustments would quickly result in useless, infinitely large numbers. To prevent this, the system uses an activation function. An activation function is a mathematical filter designed to squish any extreme dial setting into a clean, readable metric. This chart shows exactly how that filter works. The red line takes an infinitely wide horizontal axis of raw data and forcefully compresses it, ensuring the vertical output always stays strictly between 0 and 1. Bounding the numbers between 0 and 1 allows the machine to express its output as a probability. A result of 0.99 translates directly into a statement, "I am 99% sure this is a dog." A neural network never operates in absolute certainty. It speaks entirely in the language of calculated probabilities. Picture this entire mechanical process operating at superhuman speeds. The machine processes millions of images, making microscopic dial adjustments in fractions of a second. As it perfects its tuning, the guesses evolve rapidly. The output moves from wolf, then to fox, and finally arrives accurately at dog. The machine has no concept of what a dog actually is. It does not understand fur, ears, or snouts. It has merely discovered the precise, static mathematical configuration of dials that perfectly translates a specific grid of pixels into a correct label. Artificial intelligence possesses no conscious thought and holds no secret wisdom. It is an elegant machine that achieves greatness purely by surviving millions of carefully calculated mistakes.
AI isn't just another tool. It's an intelligence system for your dealership. Learn how at autoagentic.ai.
Or get your free copy of the Automotive Playbook for rebuilding organizations around AI. Also at autoagentic.ai.